Now let's take a look at another example of saving registers, and here we're going to name our registers explicitly to make it easier to remember who saves what. So let's look at some more convenient names for our registers. And you've seen before we have these nice names V0 and V1 for the return values and A0 to A3 for the arguments, but we also have a bunch of other helpful names. So these ones here, these T registers, T0 through T9, these are temporary registers. And the idea here is that if the caller uses anything in a temporary register, then it has to save it. The other registers we have here, these S0s, these are saved registers. That means that the callee has to save those. So from the caller's point of view, the saved registers are automatically saved because the callee has to save them, and it's only the temp registers that the caller has to worry about saving. So by having this naming, it makes it easy if you're writing code, if you're writing a caller, to know that you have to save the ones that are in the temporary registers, but if you use these save registers, you don't have to worry about it unless somebody is calling you. So let's take a look at another example. Here's the code for this example. And you can see we start out here setting up our arguments. We're moving different values into our argument registers. Then we're going to call update function. Update function comes down here, and what's it going to do? It's going to do a little bit of work. It's doing this function we saw before, f equals g plus h minus I plus j. You can see we have two temporaries that we use here. We end up with the results in S0, and then at the end, we move S0 to our result register to return the results to the calling procedure. So, what resources does the caller use? Well, if we take a look here, we can see the caller is using these registers up here. So it's using T0, S0, S1, and T0 and T0. It's using these values to store them in the arguments that it's going to have for calling the function. So T0, S0, and S1 is what the caller uses. Now what resources does the callee use? Well, if we go down here and look at what the callee is doing, we can see the callee writes to T0, T1, and S0. So the callee is writing over T0, T1, and S0. Now here's the interesting question. What does the caller need to save? So of the resources here that the caller is using, what does it need to save? Remember, the caller needs to save anything that's not in the S or saved registers. So the only one here is T0. So the caller is going to have to save T0. Now we can ask the same question about the callee. What does the callee need to save? Well, remember, the callee needs to save anything that's not in the S registers. So, sorry, in the T registers. So it's going to need to save S0. So now we can go ahead and take a look at putting this together. So we know that the caller up here has to save T0. So we move the stack pointer down by 1 and we put T0 on the stack. We call our function. And then when we're done, we're going to go ahead and put it back, restore the value from the stack, and put our stack to where it was. Now what does the callee need to do? Well, we decided the callee needs to save S0. So it's going to do the same thing. Move the stack down by 1, put S0 on the stack, do its work, and then at the end, restore S0 from the stack and put the stack back where it was. So, now question, why does the caller not need to save T2? After all, we're using T2 down here. Well, the answer to this is the caller is writing over T2. It doesn't matter if the callee puts something in T2, because the caller is immediately going to replace it by moving this V0 into T2. So another question, why does the callee not need to save S1? If you look up here, the caller has S1, so why does the callee not need to save S1? Well, the answer here is the callee never writes to S1. It only writes to T0, T1, and S0. So it's never going to write over or corrupt S1, so it doesn't need to save it on the stack and restore it when it's done. So now let's walk through this example in detail and go through what all the lines are doing. So we start out, we notice here from what the caller is doing that it uses T0, S0, and S1. T0 is not saved, so the caller has to save it. And we ask, what about S0 and S1? Well, S0 and S1 are callee saved. So the callee saved, so the caller does not need to save them. So we don't need to worry about S0 and S1 because we know that the callee down here is going to have to save them if it needs to do so. After the call returns, the caller is going to restore T0. And the result is in V0 and we move it to T2, and why didn't we need to save T2? Well, because we overwrite it here. So it doesn't matter if the callee corrupted it because we went ahead and wrote it over, so we didn't care about what was in it. So now the callee, when it runs, finds its arguments in A0 through A3. It uses S0, so it needs to save it. And what about S1? Well, the caller does use S1 up here, but the callee never writes to S1, so we don't need to save it. The results are placed in V0, so the value return register, and then the callee needs to restore S0 that it saved beforehand. So question, who has to save the S and T registers? Well, the callee must save all the S registers, the save registers, and the caller must save all the T registers. Those are the temporary registers. But note, you only need to save registers that you use. So the callee here needs to save any of these registers that it uses, but if it doesn't use them, it doesn't need to save them. And the caller needs to save any of these registers that it uses, but of course if it doesn't use them, it doesn't need to save them either. So another question, if a caller uses S0, S1, T0, and T1, how much stack space does it need to use for saving registers before making a procedure call? Well, the answer is 8 bytes here. We need to save two things as the caller. We need to save T0 and T1 because those are both going to be caller saved. So we need to save two things, or 2 times 4 bytes, or 8 bytes. So these are the ones that the caller needs to save. Here's another question. What value should X and Y have in the code below here to make the code correct for saving registers S0 and S4? Well, -8 and 4. So take a look at this. We want to decrement our stack pointer by 8, and then we want to offset this by 4, the second one here. So here's our memory beforehand, here's our stack pointer, and what we want to do is add -8 to the stack pointer. So this is going to move it down by 2 spots. Once we move it down by 2 spots, we store our first value, S0, to the stack pointer, and then our second value needs to get stored to this other spot, which is 4 above the stack pointer. So -8 and 4.